Hello friends, this question is from the test series number 1. The subject name is control system, topic name is root locus technique. It's a 1 marks problem. So we have transfer function k upon s into s plus 1 into s plus 2, and it's a closed loop system, and we need to draw the root locus plot. Okay, so we need to draw the root locus plot. Let's see how many poles we have. We have 3 poles, one at the origin, another at the s minus 1, and third at s minus 2. So in the root locus plot, we know that the basic law that root locus plot only exists in the real axis where the sum of the total number of poles and zeros are odd. So no root locus, root locus, no root locus, root locus. So the root locus plot is only going to exist after minus 2 and only going to exist between 0 and minus 1. So you cannot expect any curve between minus 2 and minus 1, and obviously in the right hand side. So let's see how many options we can rule out. Okay, we can rule out this option B because it is there in between minus 2 and minus 1, and we can rule out, okay, and then we cannot rule out any other thing. It is at the minus 1. Okay, and again I can rule out option D also, because you know that root locus, okay, we cannot rule out like this. Okay, let's see. And again after that, if you can find out the angle of asymptotes, then you can rule out pretty much more options also, right? Because the angle of asymptotes, how can we find? We find the angle of asymptotes as 2q plus 1 into 180 degree upon p minus z. In this question we have 3 poles, and none of there is 0, where q is varied from 0 to p minus z minus 1. So let's see that for q is equal to 0, you will have 2 into 0 plus 1 into 180 degree upon 3, angle is 60 degree. For q is equal to 1, angle is comes out as 2 plus 1 into 180 degree upon 3. So it's like 3 into 60, 180 degree, and then if the q is 2, which is 5 times 60 is 300. So angle of asymptotes is 60 degree, 180 degree and 300 degree. So your asymptotes can go to 180 degree and 60 degree and 300 degree. So your asymptotes can never go to the 90 degrees. So option D I can rule out by this. Okay, now we have option A and option B, because in option C, option A and option C also we have 180 degree asymptotes. Option A also we have 180 degree asymptotes, and option A and C in both have asymptotes which pretty much looks like a 60 and 300, because it's a rough drawing, so we cannot say surely. Okay, so now I still have 2 options. So now I can only have additional information of intercept with the imaginary axis. Okay, so I think for this I should go with the Raoult's-Hurwitz criteria, because that is the only way we can find out whether this curve is intersecting with the y-axis or imaginary axis or not, right? So just go to the closed loop expression. So the closed loop expression is s cube plus 3s square plus 2s plus k is equal to 0, because in the Raoult's criteria can only be applied at 1 plus GSHS equal to 0, right? So 1 plus GHHS equal to 0. Now you know that from the Raoult's criteria that Raoult's criteria is 1 plus GSHS is equal to 0, and here we have transfer function is GS. So 1 plus GHHS will be 1 plus k times s plus 1 times s plus 2 is equal to 0. So it will be like, finally we will have a s times s plus 1 into s plus 2 plus k is equal to 0. Just multiply this polynomial and you will get finally as s cube plus 3s square plus 2s plus k is equal to 0. Now let's draw the Raoult's array. In the Raoult's array we will have a s cube term which is 1 and 2 then you will have a s square term which is 3, and k. We will have a s power 1 term which is 6 minus k by 3. Then we will have a s0 term which is k. Routes, for stability, Raoult's criteria says that my first column term should be greater than 0, which gives the condition that k should be 0. Now if I want the imaginary action interception, which is for that my 6 minus k should be equal to 0, my k should be equal to 6. So if my k is equal to 6, I will have an intercept with the imaginary axis, and my intercept will be 3s square plus k is equal to 0, means 3s square plus 6 is equal to 0. It means that my omega is equal to root 2 radian per second. It means that I will have an intercept of root 2 with the imaginary axis. It means that my option A is my correct option, because in the option C you can see that it is going very far. Okay, or maybe it is intercepted or not, we cannot say surely. So option A is the most correct. So that's how you can see that in the routes array we know that in the root locus plot we have a 10 to 11 rules. Okay, and many rules I have applied here, because you know, if it's a multiple choice question, in most of the cases it will be in the routes problem, so you just rule out the options using the array, just like we have first of all observed that in which region routes is existing. On the basis of that I have ruled out one option. Then we have find out the angle of asymptotes, in that I have ruled out another option. Then we have find it out the intercept, whether the intercept is exist for stability. We have get that for stability we can get the intercept, that is for k is equal to 6. I am getting the intercept with the imaginary axis, and that which is equal to root 2 radian per second. So we are in the conclusion is that my option A is that, because we are getting an intercept. So with the help of all these three properties we get the right answer. Thank you.